Problem number 2 from the review. So it says construct a cumulative frequency table. You could make it on here. I went ahead and made it over off to the side. Just remember what we're interested in is the cumulative frequencies, but you need the frequencies to get there. So, and I also want to emphasize when I do this that I'm thinking about the right endpoint of the interval. Some of you are using the midpoints because that's how you found the averages, the estimated means, but I want the right endpoint and the cumulative frequency. So I have some ordered pairs. So you're not plotting the interval, you're plotting a point. So you're plotting 15, 7, 20, 20, 25, 45, 30, 73, 35, 93, and 40, 100. So the last point should be the cumulative frequency and the right endpoint of your interval. Okay, so whenever they're asking you to make that table, you're going to be plotting points. So it says use a scale. So this paper's been shrunk down, but every 5 spaces is a centimeter in IB graph paper. Okay, so it says 2 centimeters represents 5 minutes. So every 2 is 5. So it just fits on here. And 1 centimeter, sorry about all the moving. 1 centimeter is equal to 10 students on the vertical axis. So 20, 40, 60, 80, 100. If you want to add in other detail, you can. So 10, 20, 30, 40, 50, 60, 70, 80, 100. Okay. So I know the last point on here, and then I just plot my points using the best precision that I can. I'm going to pause the plot so you don't have to watch me go through this. Points are on there, and you always want to sketch a smooth curve. Don't go connecting with a straight edge on this one. That's not the place for it. You want to be able to, and again, this will be a full-size sheet of graph paper, so that's not terrible for what we have right here. Use your graph to estimate the number of students that completed the task in less than 17.5 minutes. So one thing I need to do here is label minutes, and this is cumulative frequency. So less than 17.5 minutes. So 17.5 would be right here. Draw up to my line over. Straight edge. Because there's a good chance they're picking a number that works out. So that, let's see it. So this is 10, and every unit is 2. So 10, 12, 14, 16, 18, 20. So this is 12. Number of students that completed the task in less than, so that would be anything back from here. So there's 12 of them. If they ask more than 17.5, it'd be everything above it. The time it will take for 3/4 of the students to complete the task. 3/4 of 100 is 75. So here's 70, 75 right there. Again, use your straight edge, even if it's a small graph. You got a better chance to be accurate. And I think it goes right down the line. Three-fourths of the students will complete the task in 30 minutes. Any of these other ones are less than 30 minutes, so when we've gotten to 30 minutes, we're at 3/4 of the students. It says find an estimated mean for the data. In your calculator, that is where you're going to use the midpoints now. You don't get the estimated mean off of this chart. Estimated mean, there are 7 students in this category, so 7 times 13. If we're estimating that as 13, there are 13 students in that category. 13 times 18, keep following it. So basically we're multiplying the frequency by the value. The other way is to do this using 2 lists. This way only works if you can remember how to do it. And you put the values, the midpoints, 23, etc., the midpoints of our intervals. You put those in, and then you put the frequency list over here. You're never just going to add up this and divide by how many there are. That is not telling you anything. Always remind yourself, there's 100 students in this list. I better be dividing something by 100 to make sense. The other thing that that we didn't do on this cumulative frequency, but that you can, is remember that you could make a box and whisker plot from this. So there's 100 values. You could go to 50. Usually it asks for a median. There's the median. The lower quartile would be at 25, so the upper quartile would be at 75, which they did ask. And then you have your max value and your min value. If you do that, you have a box and whisker plot right from this graph. So there are times where they connect those two together. All right, that's it for problem 2.